got the privilege to speak at a couple of conferences so where I present my research papers. I was speaker at Black Hat, Europe, was invited in Las Vegas, HITB, Amsterdam, Malaysia, Nalcon. I was speaker from 2011 to 2013, that is now Delhi, Echo Party, Kokon, and CanSec West. I'll be in Canada, which is coming. So what do I do at work? Not really. I mean, at office, I do 50% of my time I do reverse engineering. Then 20% of time I build tools. The other 10% I do a little bit of malware analysis. And 5% of your time we play Counter-Strike at office. So, yeah. So what do I do at home? I do a little bit of exploit writing. I code for my own project called KXP, try out different food. This you all do. And I do a lot of Facebooking actually. So agenda. So we'll have an introduction on USB modems. Then we'll go on to fuzzing USB modem dialer applications. That are the US internet modems actually. Then we'll explain DDoS attacks on these devices, phishing attacks, fuzzing these device drivers, and code execution, remote code execution on these devices would be done. So why a security talk on USB modems? So as per market research statistics, there are 80 million devices in 2010. The number would be more right now. And is security all about the number of devices out there? Well, I mean, yes. The quick answer would be yes. It's all about the number of devices out there. So you need to think about the security of it. So is this the only reason why we are considering this as a why I took this as a research paper? No, we'll come into this later. Actually, we'll come into this soon. So these are the various devices which you can see in India. You have Airtel over there, Reliance Net Connect, Idea NetSetter, Reliance Tata Photon, and BSNL 3G. So I think you guys would be one of the users of these devices, right? I mean, either one of would be your service provider. Can you spot what is the similarity? I mean, what is common in all these devices? Can anyone say what is common in all those devices, apart from the fact it's an internet modem? Huawei, yes, Huawei, the Chinese dudes. Anyways, so all those devices are marketed by Huawei. I mean, it's made by Huawei. The hardware is made by Huawei. The software is made by Huawei. I'm not like blaming Huawei as a bad guy or something like that. But the entire India, Huawei's product is sold. That means the entire nation is using just one product, one application installed on every computer. So I just got interested, and so we'll get into all the interesting stuff. So let's give me a quick introduction on USB wireless modems. They are commonly used for wireless internet access actually. They use the USB port on your computer to connect to a CDMA GSM network to give you internet access. So you just plug this modem into your devices as a USB modem. Then it will give you a point-to-point Ethernet interface, and it will connect you to internet actually. So this is the basic thing what it does. And it also comes with a dialer. That means first time when you use it, you have to install a software which comes bundled with these devices. So those are we are going to call them dialers today. And they also come bundled with a device driver. That means your computer, if it's a Linux, Mac, or Windows, they need to interact with this USB device. So they also come bundled with a device driver. So the most important thing is the mobile phone service providers distribute them. All these service providers distribute them. And these modems have a phone number. I mean, all the modems you have, it's got a particular phone number. I mean, because it's got a SIM in it and it's got a phone number in it. And if it's a Tata Photon, from my number, let's say my number is XXX1000, and to XXX2000, it would be the same device. That means from this particular number to this particular number, all would be running Tata Photon Plus. So that means if you are able to find an exploit in one of these devices, you can do a mass exploitation. It would be like a MS-0807 exploit. Just that you don't even need to scan a modem actually. You know where this device is. You just You just know the number. You just have to put this particular number to this particular number in your exploitation tool, and you can mask on. So it's like it's like a very bad thing actually. So a little bit of technicality on this modems, USB modems. By default, they come as when you connect it to your computer, they are detected as a CDFS file system, and there will be this following applications you have to install. So it all comes bundled as a single application. You have to double click that installer. You install. Once you install, a network manager would be installed, a device driver would be installed, and a modem dialer would be installed. So these three softwares come packed together, and they would be installed on your computer. So these are the three packages, the above mentioned packages, which are found in Huawei USB modems. And like I said, Huawei modems market provides the same software to all the service providers in India. So they have a different name, but this is the same package which is on every modems which are distributed in India. So this is the architecture. The device driver is there, then the dialer app is there, then a network manager is there. So the device drivers, once you install the work of device driver is to interact with this USB modem. Let your computer interact with the USB modem over here. And the dialer app is the one which sends commands to the, once you establish the connection, the dialer app is the one which sends commands to the USB modem, and and the modem responds back. And the network manager, once it connects to the a GSM network, it provides an IP address to your local computer and all. So that is what the network manager application does. So where are we going to, I think, yeah, this is not needed. And yeah, and by default, they provide support for all the three operating systems. That means Mac, Linux, and Windows, they provide support. And this, like I said, let me explain how the modem dialer works. Modem dialer is nothing but the interface which you click and dial and connect to the internet. It uses AT commands, AT&T AT commands as the modem commands to interact with the modem and look for responses. One of the interesting features which we are going to attack today are these devices. If you have noticed, they have a feature to send and receive SMS. Have you noticed that? Send and receive SMS. So this is mainly done for promotion purpose actually, just sending spams from the service provider, like you got this offer and it will come directly on your computer. So that is what modem dialers does, and the network manager, I already said what it does. So what are we going to attack today? We are going to show phishing attacks using SMS campaigns, because they are going to receive SMS directly on your computer. So we'll explain phishing attacks that might happen. It is not right now there. I don't know if someone is using it, but it might happen. I'm not sure. SMS passing modules. Then we'll explain attacks on the SMS passing modules. These devices has to pass the SMS which are sent to the computer and display in a text format, right, on your computer. So we'll be fuzzing the SMS. We'll try to find bugs in it and try to exploit it via SMS. And then we'll have a little, I'm not sure if time permits, we'll show attacks on the device drivers as well. So, so this is how the modem once installed and once set up looks. So it is right now it's not connected actually, but it's connected to the GSM network. So you can see the range over there. It's connected to the GSM network. You can see the range over here. So it's connected to the GSM network. Now it's got the option to 1 minute. Oh, it's not playing the video. Yeah, 1 minute. Yeah. So right now it's connected to the GSM network, and it's like, it's in active mode. As soon as you connect it, it just connects to the GSM network. So now it has so this is what happens when it receives a message. It can directly receive a message to your phone, and it gets passed and displayed over there. So this is how the future works. So everyone is clear about this operation, right? So this is very basic. You can send directly an SMS to a computer as soon as it connects. So the first attack we are going to talk is a social engineering attack. This is something which I found back in college, where my ex-girlfriend used to get a lot of prank calls from an anonymous number, and she was like, "Can you trace this number?" So for tracing the number, you need obviously you need to be a government official to trace the identity of a number. But I found this very successful attack, a social engineering attack on this customer service, where you'd be able to extract the address proof, last send message, past call details of any phone number. So we'll explain why we are going to do this right now. So imagine, once again. So imagine, can you see what happens? You can actually send links as well as in an SMS. You can send a link to a user stating that, actually that is a link to a binary actually. It's stating that, dear customer, this is IDEA customer service. You need to download, install this application for continued internet service. So you can do this sort of mass phishing attacks on users using SMS. But most of the times, if you just say, dear customer, people won't just install this application. So what we try to do is, we'll try to find out the address details of a particular user, or the phone number, or some details of a particular phone number. We'll put that in. So dear Ragesh or something, this is in IDEA net setter. You did a recharge for this particular amount and it didn't got worked. So can you just install this application? So it becomes more genuine, right? So this is a call which I make to the customer care. What I just ask, what I do for the attack is, for every customer service, there are two things which is necessary to provide you information. If it's they won't just give you the address proof if you just ask for a number. They need a verification. The verification is, you need to provide, what do you call, if I'm saying that this is my number, can you provide details of it? They'll ask for you for the verification. That is your name, or they'll ask you the last 3 recharges you did. So we don't know. So what I did was, yesterday I took Himanshu's phone number. I said, I'm going to trace every details of you. Wait, I'll show you the call.
You have not.
I'm sorry.
Okay. There is no application of 50 rupees or some of the recharge.
So what I do is, I don't just directly ask for details of a number. What I do is, I tell that I did a recharge for rupees 50 and the balance is not, I took Himanshu's number, so I did a recharge for 50 and the balance is not visible on my account. I didn't get the money credited. So he said, so let me check the account. So he just asked me to hold, look up on his computer.
There is no application. 26th of February at 1 o'clock 8 minutes, you done a recharge for 3, correct? 26th, what was the amount you said? 8.
So once he checks on his computer, there is no recharge for 50 rupees because I didn't did, or I was just trying to get Himanshu's details. So he said, sir, there is nothing done for 50 rupees. I said, I did something for 50 rupees. How can you say it's not there? So then so he started like looking for other past details and started reading out the information that on 19th you did a recharge for 333 and on 26th you again did a recharge for this particular amount and on 29th you did.
I did a recharge on 26th. Yeah, after that there is no top-up recharge. Sir, what about, okay, 26, yeah, I did. Okay, I did. Okay, what about before 26? What did I do on before 26? Okay, before 26, actually. On 19th of February. Okay. Okay.
So you started reading out all the information which you have on the screen. So next attack, all you have to do is end the call another guy, tell him that this is my verification, do my verification. I did a recharges on these many details, so I am the owner of that number. Just now read out the address proof and he will do it. So anyway, Himanshu asked me to stop over there. So now imagine now I'm going to get Himanshu's details. I'm going to send Himanshu, say, dear Himanshu, this is what happened. Can you download this application and install for further internet access? You will do it, right? It becomes more convincing. So something like that can be done. So that was the fun attacks just to cheer you up. We'll go on to the serious part actually. So what we'll do is today is we'll be fuzzing the SMS parsing module. So as soon as an SMS comes, we find vulnerabilities in the SMS parsing module. We'll fuzz SMS, we'll find a vulnerability and we'll try to exploit a computer using an SMS. So this parsing takes without user interaction. So as soon as an SMS comes, there is nothing you have to do. Everything takes place in the background. So it's like pretty convenient for an attack. So let me tell you how the SMS architecture is. When I send a message to a particular user, it doesn't go directly to him. It goes to a MSC, message service sender, and from the message service sender, it goes to a SMSC. And the SMSC forwards it to the user whom you want to send it to. So even if I find an exploit and I send it, at some point when he comes online, he'll get exploited. So you can run, you can hide, but you cannot escape these sort of exploits. Understanding SMS actually, when an SMS send, it is, I just explained, and actually there is a limitation for SMS. You can only send a 140 character SMS when it's actually 160 character when there is an encoding actually. When if it's a 7-bit character encoding, you can only send 160 character, and if it's a 140, it will be 8-bit encoding, and if it's 70 characters, then it's 16-bit encoding actually. So there's a technique called SMS concatenation. So you have seen like you have sent big SMS, right? What happens is these SMS are sent individually, and in this SMS there's a bit set stating that you have to, the receiver end has to concatenate them together. So SMS will be sent separately, only the receiver end knows that it's the same SMS, as soon as both comes I have to put it together. So that is called SMS concatenation. You need to, and SMS can also send OTA configuration and binary data. So these are the ringtones and all you can send via SMS. So this is how this is an example of the parser working. So it is listening to connection. Message came. You can now view the messages. This is very clear actually already. So let's move on, skip. So this is a 37-bit character ASCII encoding which is used for the encoding thing actually, not useful. So SMS handling by modem. When an SMS arrives on the modem, the dialer sends a net command to the modem asking, did you receive something? Is there something on the modem new? The modem responds back to the net command stating that this is the SMS format which is received right now. Parse it. So dialer communicates to the modem responds back. So SMS format is called PDU actually. So this is ugly, right? This is actually, when you send an SMS, this is the actual format which is being sent over the GSM network. I'll explain what this the format is, how this format is. So this is a chart explaining the format. On the top, that is an SMS actually. That is how an SMS actually looks in the binary form. The first, so this is a chart which explains what individual, what the format is. I'm not going to deep into that. You can just read the slides. So this is the format of an SMS. It's got a lot of variety of things to pass. I mean, the dialer has a lot of things to pass. So this is an example actually. You set the SMSC number. This is actually what happens when you send an SMS. SMSC number is by default set. You enter the receiver number, then it will automatically choose the encoding actually 7-bit, 8-bit or 16 bits. Then you type the message, and so this is just to explain how the PDU format works. Convert, and so that will be the actual, on the other side it will come, that will be the actual SMS which would be sent from your modem, from your phone or whatever to the other device. So, and the decoding end, I mean in the parser end, when an SMS is received, the following has to be converted back over the XHTML PDU messages, convert, and it will bring back to the text form. This is the actual parsing which is done in the modem. So now that is clear. So how do you fuzz these devices? and created our test cases. So we didn't create the fuzzer, we used an already existing fuzzer and implemented the test cases on top of that. So my fuzzer, what it does is it'll read an SMS format, add a victim number, that is my own number, and send to it's a phone actually, my phone will send a particular first test case to my modem. And if a crash is occurred, stop there, else continue the process. So this is like, it's a very lame approach actually. This is my first approach, very lame approach, just to see if it was something I could find. So you're sending in the SMS over the GSM network, see if it crashes over there. If it crashes, analyze it. So this was my basic fuzzer architecture, and I found a bug in Huawei actually. This bug, you can remotely crash any Huawei modems, actually every modems in India, via an SMS. I'll explain the bug. We reported, so, oops. So, okay, so now the SMS will come. You can see the PID, I mean the process is running, Huawei process is running with PID 7367. As soon as an SMS comes, I mean the vulnerability SMS comes, the modem will crash. It's gone. So now once you have an vulnerability actually, you need to convert it to an exploit, right? But without even going to make an exploit module, what you can do is you can actually DDoS you can take down the entire network by sending one SMS to each phone numbers. So like I said, actually I didn't do this is just a screenshot just to show the POC. I haven't done this particular thing. Send one of these test cases to one of these modems, starting from this particular number to this particular number, and all the devices will go offline instantly. Or as soon as they come online, they'll just go offline. So now what? Well, I reported this to Huawei on January 26th this year, and I explained the bug actually. I sent the POC crash, I sent them a detailed bug report on how to fix, what was happening. And those dudes didn't respond back. Till February 5th, they didn't respond back. And on February 5th, they sent a Chinese New Year greetings. They still didn't respond me back for my bug, but they sent me, this is Huawei product security team, happy Chinese New Year and blah, blah, blah. So I keep waiting. And on February 11th, they sent me this mail. I was not in India at that time. They sent me a mail stating that, dear Rahul Shashi, not to my email, by my second email, they found it somehow. Dear Rahul Shashi, we found you have a presentation on SMS to Meterpreter at Nulcon and CanSec West, that is in Canada. Will you please tell us whether this vulnerability affects Huawei modems, and can you share the POC with us? I was like, dude, I already sent you a bug report. Just respond to that. And they were like, oh, we are sorry. We are sorry for not responding to that bug and all those things. So then we had more interactions. We started, I sent them more POCs. And on February, what was the date? Yeah, February 26th, they fixed the thing. They updated on the site that this particular bug is fixed. The interesting thing is, there is no auto update. Now, who I know there is a bug, there is no update on any of these devices. And Idea, Tata, Reliance, or whoever these people, they keep selling what is there with them. It will continue till another 2 years. It is fixed, but it will not come on your modem. You will never get the update because there is no auto update. And nobody is going to, they only update it on their site. Nobody goes check their sites to see something is happening, right? Nobody does it. Yeah, so it's pretty lame actually. They didn't even have a security response team. Last year, a researcher called FX Linder, he presented a lot of things in DEF CON or something, and it becomes a huge media news. Then they started incident response team itself. And I exchanged mails with them. He said this was my same response. They didn't even respond to any of these things. But once I started talking in conferences, they were like, oh, we are going to talk to that guy. We are going to do this to that and all those things. So the main thing is they have a bug, which I sent. They know there is a bug, and nobody has a fix for it. But they said they have a fix. Now, I'm not blaming them completely, but the approach is very bad actually. So more lead fuzzing. So this is something, you can actually find vulnerabilities in SMS and you can get it exploited. So I did more fuzzing actually. The approaches, I'll explain the approaches I took. So now I know that these sort of bugs exist and I can find vulnerabilities in these sort of devices. So I started, I thought like I should be more active. So I started reverse engineering the dialer application, see what all modules it parse, what all thing it does. So actually you don't need to spend much time reverse engineering the application because there is an easy way of doing it. You can sniff the USB traffic actually. This USB traffic can be communicated when your dialer communicates with your modem. All what you need to do is we need to understand what all things are communicated with the dialer and the app so we can build more better test cases, right? So I started sniffing the USB. These are the two tools which can be used. The first one is for Mac and the second one is for Linux. You can use Wireshark default and the other one is for Windows. You can sniff the USB traffic and you see what is happening between the computer and the dialer. So this is a video on how the sniff actually takes place. This is on my Mac, the tool called USB probe. So this is the attached USB device. Number of endpoints is 15. I don't have time to explain those things, but we'll have a detailed white paper on that. Go. Okay, so anyways. There was an explanation of all these things, but we don't have time. So we'll just start the sniff. Then we can just log all the activities which is happening between the modem and the thing. And now we can easily understand, instead of reverse engineering, we can easily understand what is the dialer trying to communicate with the modem and what is the response and all those things. So this is what actually happens. So these are like, see the hex. These are the commands which are sent to the modem. We can easily get it from this particular approach, sniffing. And yeah, so I'll explain what was the information I was gathered. First, the modem sends an @sysinfo. The command is used to query the current system information. Then it sends, then it asks the modem to select a network. That is, I was using IDEA, so it was asking to select IDEA service. Then this is the interesting part. This is the command which tells the modem to save all the SMS which you received on the SIM. And all the SMS which have to be read has to be read from the SIM. So at CPMS, this is the command which we got from sniffing. So how can you make a better fuzzing approach? Like I said, Colin Muller, Charlie Miller and all, their approach was they had a layer, they injected a layer between the modem, the phone modem and your fuzzer. And they started, whatever comes here, they just fuzz and send it to here. I was not neat enough to build such an architecture. So what I thought was like, if I keep writing SMS to the modem directly using a different application, just attach the application to your Python program, start writing first modules to this modem, set the unread to 1, that means the message is not read, detach it, attach it to the dialer, and if there is a vulnerability, it will actually crash. So you can actually write n number of SMS to a modem, detach it, attach it to the other thing, and if you have a crash, it will crash when it passes. So whatever was tried to crash, we can find that was the bug. So anyway, that approach really worked. I couldn't find like an exploitable bug on Huawei. I couldn't do it actually, but maybe like better leads are out there. You can once I release the POC, if you can work on that. So this was my current fuzzing approach, the latest one: read SMS, send SMS, set the SMS sender. Set the SMS sender. Then set the PDUs unread to 1. That means this message is not unread, this message is not read, and send it to the dialer. So if it can't be passed, it will crash and then you have a bug. Yes, we got some good, we started fuzzing the BSNL, I'm sorry. Everything except a particular model of BSNL is not owned by Huawei. This is done by a company called 3G Connect, I don't know which one. So we started fuzzing on those devices. We found one exploitable bug actually, which is not fixed yet, so we wouldn't be releasing that bug, but the other bugs we can release because there's a fix for that right now. And the worst thing about these sort of exploits are, if you show the demo, is no antivirus and firewalls can detect it. Why is that they can't detect it? Why is that an antivirus and firewall can't detect it? Yes, because this is actually an attached GSM network. This is not an Ethernet or a wireless network connected to your computer. This is a GSM network, which is you attach a GSM network to your computer. And no firewall or antivirus currently in the market looks inside the modem, sends a command, add commands to the modem, and reads something out of it. There is nothing available actually. So, it's pretty bad. So we had this bug. Oh, I'm sorry. So this is actually the code execution part. So this is the C drive. There is nothing. There is no text file right now. There's a limitation actually. So just for the proof of concept, our shellcode was just create file. Nothing else. Don't write or anything like that. Just create a file. That was our POC. So in the C drive there is no file right now. This is the BSNL modem actually. It's some company called IG, so I don't know. I mean, I couldn't spend much time, doing that. So as soon as an SMS comes, this gives you a sound like the Windows, boot up sound. Yeah, you heard the sound? So SMS is there. So this is just a test to show that this is how it receives SMS. Now we will actually send the exploit. We attach it to that was the debugging thing actually. As soon as the SMS comes, it crashes and a file will be created called hack.txt. Hack. So you can actually have a code execution. You can actually have a code execution with that particular thing, but we still can't, make it there's a lot of limitation actually, and I'm not really awesome in exploit writing, and this is something new. But if I spend more time, maybe I can actually get the SMS Meterpreter. But right now, this is just a POC. This bug, I don't know, it's not fixed yet, but the rest of the bugs are out there for you to play. So if you can, actually exploit a Huawei, I don't know. It's bad for us, but so oh shit, yeah, that's it. Oh, I mean, I would like to thank actually Muslim Kauser, Praveen, Sumit Sharma, Abhay. Those are the friends just helped me a lot in all those things, and they're very supportive. I obviously don't have a girlfriend to thank, so these are the people who would like to thank right now. Any questions? Yeah, I'm done. Any questions? Yeah.
The SMS that you sent for the remote exploit, okay, was it over the network or directly through the USB?
Actually, once I was testing it, what I did was I just wrote the exploit directly to the modem, then attached it to the thing. So I can't actually every time, when you debug it, you can't actually send it every time. It's very hard. Yeah, I get it. You can't send things via network, right? Certain things.
Yeah, because even if it has to pass, for example, you said the SMSC, it has a passer of its own. And if it's a malicious message, it will drop it over there itself.
Yeah, see, that is a part. That is a part I talked with that Nico Goldie actually. They did a lot of, they mainly do a lot of research. So we had a lot of communication on this. It is possible actually. There is it is not very foolproof. SMS is not very foolproof. You can easily bypass that particular, what do you call it? That you need a non-ASCII payload. I mean ASCII payload, and a couple of factors are there, but you can easily bypass that. But I didn't have enough time to and resources to individually send every time and just test it. But this was just a POC, so this was the way I did. But I think people can extend it and make it more more harmful. But then again, it is going to come bite back us. It's not going to. Yeah.
So as you said that once you send an SMS, right, it's getting crashed. But now that SMS is already in database, so every time you will connect and every time.
So as soon as we send a crash SMS, it's there in the modem. So unless and until the SMS parser is not able to pass it, every time you start the dialer, it will crash again, right? Because it's never able to pass this thing. But the thing is, by default, Huawei has two options. You can send the message directly to the SIM card and keep it there. That is not by default. By default, it is as soon as an SMS comes, read it, delete it, and then parse it. So this is the routine actually, so it get deleted. But if you choose the option save in the SIM permanently, you can now use the modem unless you do, I don't know, yeah, flash it again or something. But by default it was not like that. Someone there, yeah. You are not using? Okay, so you are safe. You are using a W. So no, this attack is only on the parser module. So mainly Linux users would not be. Like, Linux is always awesome. So you would never be. Since you are using a W dial, you would never be victim to these sort of attacks. Only the Linux Windows users who use the interface and all would be. Yeah. I don't think they will ever collaborate actually. I don't see Tata and Photon collaborating. What do you think, sir? They will? No. They would never do something like that. And Huawei, I don't think they would ever want something. They're not like very keen in us protecting something like this. Yeah, I'm sorry, I'm not blaming. Any Huawei guys here? I was expecting someone from Huawei. Yeah.
I'm from Huawei, but I developed drivers for them.
Oh, you develop drivers for
Yeah, not this one, but the other. Basically, these are Linux drivers. They're just ported.
Okay.
SMSs are only read. They are not executed. Even if you are able to send the SMS, how is it crashing?
The parser, the dialer is passing the SMS, right? No, it's passing. It's a vulnerability actually. It's a memory correction vulnerability which is converted into an exploit. We send a vulnerability SMS which has got a memory corruption, and the parser is actually getting the code execution. I think that is it. I mean, you can catch up actually if you have more questions. So that is it. Thanks a lot.